Alright, let's get to it. Alright, let's move some things around here. And, okay, so we need to get the project open, because my computer rebooted. So, let's see, what do we need open? Well, we're going to need two editors, as usual. Let's go into our library. Say we're working on PAINT5D, right? So let's open up PAINT5D data, and then the functions file. So PAINT5D data. We'll put the data file over on the left side, data on the left. And we will put the functions file on the right. Okay. We don't need to worry about that. So last we checked, the program was compiling. However, the new shader code we're writing has a syntax error in it. So the first thing we want to do is just get our bearings and get this running again, right? And so when we go through the different shader slots, the first shader slot says it has a syntax error. So if we look at, let's see, unexpected reserved word if. Okay. So somewhere when we try to insert our new functionality, we made some stupid mistake. So let's figure out what that is, and then maybe figure out a better way to do what we're trying to accomplish here. So in the mod folder, we're going to have to keep a folder for mods open at all times, because we're going to have to go back and forth between this stuff quite a lot. This needs to be deleted because it's going to be re-instantiated every time the program boots up, but it's going to be instantiated from some source code that's injected into the executable. So if we go into our library code, we have the PAINT5D default shaders. We also need to keep this open as well. So maybe, you know, put this on this side, or not, Windows E. Okay, so let's try to get our bearings here. And this is why I like to keep everything open, because it takes a while to get everything back in place if everything gets shut down. Okay, PAINT5D default shaders, and we also want to delete stuff that is in the mods folder. Okay, one more thing we want to keep open. We also want to keep open just the main project folder. So when we want to rebuild, we can just kind of click this. So that's a lot of stuff that's open, but oh well, that's the way it's going to have to be. This is not aligned. Hold on. I don't know what's with the windows and aligning. Okay, anyways, whatever. We're good now. So let's look at this shader code and kind of see, well, what do we do here? What's up with this? I know we kind of injected some code just in the middle here, and the idea was to just get something working right away. And whatever we did here is not it's not quite working, and I don't know why. Void main, whatever. You know, this is like a cut and paste from yeah, undef U32, UN32. I mean, it looks fine to me, but for whatever reason, that's not working. So the first thing we're going to do is we're just going to do a sanity check here, okay? Sanity check, if we, you know, comment this out within the source file, and then we try to build this again, is the shader code going to work? Or is there some other mistake somewhere else? You know, let's just get a little sanity check and say, okay, sanity check says that somewhere in this code there is a mistake. So I mean, I really don't know what the mistake is. It said that there was an if being used here, or that the mistake said something about an if. And I don't really see anything that would signify a problem like that. So I think the first thing we want to do here is just eliminate some variables, right? So let's actually kind of get rid of any extra noise in here that could be, right, like I don't think it's a problem, but getting rid of extra noise could be helpful. This U32 as uint, I kind of like it like that. I would rather not have to change that now. Does this function need a semicolon at the end of it? So if we look at this void main, right, so we gotta scrutinize all little kind of syntax things, and no, the function does not seem to have a semicolon at the end of it there. So I don't really see, possibly the return statement is wrong. You know, maybe, I don't know. I don't know what's up with that. So let's just give this a shot, right? Let's give it a shot and see if maybe that'll fix it. We have to go into our mod folder and once again delete this. This is going to be very tedious. This is kind of why I wanted to be able to use Shader Toy for most of my development. But then Shader Toy doesn't really have all of... The problem is that I have data that is stored in a very specific way in a texture. So I can't really use Shader Toy. Okay, so syntax error still. So what the heck, man? Syntax error, unexpected at token. Syntax error, unexpected reserved word if at token if. So the thing is, what's up with that? Like, why is that a mistake? I don't really get it. I don't know what the problem with my code is. And we gotta figure it out. So let's... So instead of this, we're gonna have to comment this out. And what we're gonna do to figure out the problem is we're gonna make the most basic function we can possibly make and see if that fails on us, right? So int some function, and it's just going to take 0 parameters. Actually, no, it's going to take 1. It's going to take an int whatever, and then it will return 0. Right, so this is the most basic function I can think of. So let's just throw that in there and see if we can get that, or if that's not going to work. And then if that doesn't work, then I'm kind of lost as to what's going on here. Okay, so delete that and rerun this and see if there is a mistake within here. Like, I don't know, man. So, okay, so that works. So the question is, why didn't the other stuff work? Like, what is so does about this? Like, does it just not like my formatting? Does it not like my lax comma formatting? That should not matter. However, you never know. You never know what's going on. So the next thing I want to do is what we're going to do is we're going to take this code here, and we're going to slowly turn it into this code, right? And that way we can kind of get an idea of why it hates us, I guess. So the first thing I would like to do is just take this code and format it into a style that I more so prefer, right? So the style I more so prefer would be like so. Okay, this is kind of the style I would go for if I wanted this in... If this is actually code that I'm writing, this is the style I'm going to go for. And now the question is, without changing anything except for the formatting, is this going to... Oh! Hey, sorry, just, sorry. Yeah. So... Yeah, data-oriented design is going to put a lot of emphasis on data structures and writing code that usually want a code that the machine is more machine friendly, right? We want the code to run fast. We also care deeply about the actual organization of the actual bits as they are stored on the machine. For example, I'm storing like a quad tree-like structure for how I'm storing my tile map data, and there's a very specific data structure for how I want to store it, and we can't just encapsulate things when we're doing data-oriented design, because if we change the data, we have to also change the code, if that makes sense. Hold on. So let me get some diagrams here. So right now we are working on like a PAINT5D editor, and this editor is going to be kind of like MS Paint, except you can have pixels of different sizes. And so we can have very small pixels or very large pixels, and all the pixel sizes are like these powers of 2, and we have these different layers and whatnot. And this is like my data layout for how I want the tiles to be stored on a bitmap inside the GPU. God, there's a lot of, here, so here's some demos. I don't know if you're already gone by now, but, so I'm working on, actually, let's just open this up for a second. I'm working on a new engine, and there's a lot of pieces going into it. So I'm sorry I'm not very good at explaining what's going on here. But I had this old game I made, and it used like tiles, in an old school game you have like these things called auto tiles, and I'm trying to redo auto tiles in a more advanced sort of way. So if you can see here, we have these like tiles that I can set, and one of the features of these tiles that I'm setting here is when you zoom into them, you don't lose any resolution. So if I go zoom into these and make each tile 256 by 256 for a second, we still get all these nice details right here. So I can erase these, I can put them down, and they all latch together nicely as well. All right. Also, let's look at what else we got here. So, also within a tile map, like I want to do tile maps that would be in an old school game, but I don't want to use old school graphics, if that makes sense. So here is 3 versions of the same tile map, and this tile map has different layers, and I can apply different lighting settings to the exact same map to get it to look drastically different. So here's like foggy morning, here's sunset, and then here's like starry night. These are all the same exact tile map, but they have different rendering settings applied to them. So the idea is that a lot of people think that in order to get better graphics than 2D, you have to go to 3D, and I don't think that's true. I think that 2D graphics can keep on getting better and better, just as 3D graphics keep on getting better and better. So yeah, I made this game, and this is a little screenshot of that game. It's basically this bomb game where you can explode different pieces of the level, and when the level explodes, sometimes there's like these chain reactions, right? Chain reactions from things falling apart, chain reactions from bombs that are linked together. But anyways, I gotta get back to writing the code. But hopefully, the demo reel thing will be kind of interesting for you. And I am going to message Yeah, so when this code gets more interesting, I'm going to have a tech demo day where I show off what I'm working on. Right now, it's not as interesting because I still am building the foundation of what I need to do. So let me delete this. Okay, let's rerun this and see if the formatting changes to this code break the GLSL code here. Okay, so that still works. So the question is, what is it that's different about this that's making it just hate me, I guess? So the next thing I want to do is I just want to throw these defines back in here. See if I can get these defines. I don't know why the defines would be causing problems, but, you know, it could be the defines. So I'm going to... ooh, you know what? Oh, I know what's going on. It's, I already figured it out. So defines need to be on their own line, and this string has no new line characters in it. So I'll show you exactly what the problem is. So if we go over here, and let's just delete this shader. Oh, also, let's look. Let me find, I gotta find them for a second, but if you're still around, I'm gonna find the data-oriented design talks, and actually I'll message you with them in case you're still not, if you're not around. So, I believe this talk here, let me make sure that's the correct talk. I have both of them somewhere. Let me see which guy this is.
Sorry, let me interrupt you before I get lost.
All right.
Okay, so you gotta watch this guy. I'm gonna send you a message really quick, so that you can have that. So let's see, how do I do this? I think if I click on you, I'm gonna whisper. So there you go. Okay, so I sent you the link, in case you're still if you're not around, and you can check that out. Okay, so if we give that a run, let's exit here. Yeah, let's give this a run. Yeah, totally. Yeah, it is a long talk. Yeah, I usually will do stuff like that when I'm doing something kind of boring, where it's like, it feels like a waste of time sometimes to like clean stuff or do dishes, but it's things that need to be done. Okay, cool. So we got a syntax error, and I do know why that is now. So here we actually need to inject new line characters. And if we look at, if we look at the other part of the shader string that's encoded into the source, we have these new line characters. And we actually need to do that here. So new lines usually are just like a, new lines in source code, especially C code, are just about making it nice for the coder. It really doesn't usually matter for the computer, except for when it comes to defines, because defines actually need to be on their own line. So now that I'm pretty certain about what the problem is, I'm just going to be confident that I know what the problem is, and go over here, and I'm just going to delete this. I'm going to put it back in here, and right here, I'm just going to say \n like that, and now everything is on its own line here. And if I do that, I bet I can get this to actually run. So I do need to find a better process for working on this code right now, because my GLSL pipeline here, kind of having to restart the project, make a little changes to my GLSL, restart the project, make a few changes to my GLSL, that's kind of annoying. So that's still, okay, so we still have a mistake, huh? So, well, let's see what that mistake is, though. Let's go over to, so let's look at this shader code and see if it looks kind of weird, where I injected that code. So if we look at, so U32, here's my things. I mean, it does not look odd to me at all. It looks fine. So I guess I took too many steps. I got too confident, and we're going to take away this U32. We're going to remove the U32s because I'm going to guess they're causing trouble, and that means we got to do a uint and a uint like that. And we'll see if that helps us at all, or if we're still in hot water here. Okay, give that a run. So, I mean, we have these parameters. Maybe it just hates our formatting. I don't know why that would be a problem, though. Okay, so let's see if there's a different mistake here. Implicit cast from int to uint. Okay, yeah, that's fine. So it's a different mistake. It's, so OpenGL is almost like C code, but it's not quite like C code. So, you can't do implicit casting, right? Like, if this says it returns a uint, then this is 0. 0's any number that doesn't have a decimal point on it, by default, is a signed integer. So this is a signed integer right here, and it has to be casted to a uint. But instead of using a cast, we can do a constructor here. I don't even know if we can use a cast in GLSL, if it'll work that way. We could try. We could mess around with that and see what happens. Oh yeah, let's go over here and let's delete this again and give it another run. And also, I don't really think I need... I have too many folders open. I don't really think I need... Which folder don't I need open? I need that one open. I have to delete that file. Yeah, this thing is just a distraction. I'm going to close that. Okay. So now, let's see if it works now. Okay, cool. So that shader is working now. I am curious to see what I can do with this code. Like, if I can take this, instead of doing uint like that, if I can do a C-cast, and I don't know if that's the case, but I'm just going to see if I can do a C-style cast instead of a constructor, and see if that is also valid, or if it will complain to me. Just because I need to know what I am allowed to do here. And it does not like that. Does it... OpenGL does not allow C-style casts. Okay, fair enough. So, not allowed. Now I know. So, so it's not quite... Yeah, so this code is not quite C code when it comes to GLSL. GLSL is very C-like, and it's like, you could think of it as a subset of C, but it's not quite. It's almost like, it's very close to a subset, but then they removed some things as well. So GLSL, I believe, is based on C99. Okay, so I think I know the basic problems that we had, so let's try to add some things back in to get our basic function that, you know, it doesn't do anything yet, but it has all the parts that we want, right? So One of the things I like to do is use, well, define U32. Well, what is U32? U32 is going to be uint. So uint in GLSL is always a 32-bit integer, so I would just like to make note that it's 32 bits and use my own define for that, so I can have my own type name, right? So I can use this U32 in my code. And if we do that, I think our code will actually still work, but we gotta test it out and see if it does. Also, these windows are on the wrong side, so let me move these around. So, yeah, okay. So put that over there. Okay, if I put these... Oh, well, now they're the wrong things, okay. So if I put this, paste that there. Okay. Yeah, my tabs, you can't really reorder tabs in Windows, so I just wanted to put everything in the right positions so it's easier to work with. Okay, so now we'll see if this works. Okay, so we just suck here, I guess. Unexpected token, expecting OR at token, blah, blah, blah. Oh. So I already see what we did. So yeah, this is, I do need to find a better way to do this because this is so tedious. And hopefully, you know, once I hash out the basic mistakes I'm making, hopefully it'll be a little bit faster, but I really need to find a better way to do what I'm doing here. Okay, let's give that a run. And a lot of times, you know, I have been told one development strategy is write a little bit of code, run, write a little bit of code, run, write a little bit of code, run. And sometimes that strategy just works pretty well. It's painstaking, but it works, right? So, you know, hard-earned... I'm going to hard-earn every single function and line of code I add in here. Okay, cool. So that works. Now the question is, well, what logic needs to go in here, right? We need some type of logic for this shader code. And we wanted this function to be just a rewrite of the CPU side version of the same code. So we're going to go into here, and we're going to look for this exact same function. But instead of looking for OpenGL PAINT5D get, we're just going to look for PAINT5D get, right? Because we namespaced the beginning namespace, instead of calling it OpenGL, we namespaced it AAC 2020 based on the project name. So, okay, so we're calling it a lot of places because we kind of thoroughly tested this function. So we probably should have just looked at the beginning of the file. Here, we're gonna go all the way up, then we're gonna search forward. There we go. Or not quite there. Okay, so here we go. Here's the function we want to look at. And if we look at the signature here, we got tile quadrant, tile exponent, tile layer, location, tile x, location, tile y. Or actually, that's not location, that's local. Local tx, local ty, and the offset dex. And here we can see the same things, except this last parameter is a tile value, right? And we're returning as an output parameter. However, we can't get away with that if we're doing GLSL code. So it would be nice just to be able to write this once somewhere and then include it in a shader string somehow, and then include it in some source code here, and then be able to test it on the CPU side, and then just copy paste it over here. It'd be nice to just be able to copy paste this function here into here with some type of macro fanciness, but it turns out that's a lot harder. That's a lot harder than you would think, so we can't really do that. Also, OpenGL does allow you to do like an include-like behavior thing where you can include different files and kind of concatenate them together, but it would have to read that file from disk, and if it reads that file from disk, then, well, that might work. Alright, yeah, see you around. Yeah, so I don't know. I don't know what I'm gonna do here. We could write a version of this function that doesn't return by an output parameter, just so that we can get this working. So we could like cut and paste it. That could be a thing. I think that would probably be the easiest thing to do, and then we could also test it separately as well. So I think I'm gonna do that. I think I'm gonna do because it's gonna be a pain to get this kind of functionality into the code. So it'd be nice if we could just write a CPU side version of the code, and yeah, if we write a CPU side version of the code and we try to avoid anything that would make it so we can't just cut and paste it and put it into here, right? So let's give that a shot. So what we're gonna do here is we're gonna so this is PAINT5D get. Okay, so we're going to take this signature here, and we're going to go all the way down to here, and, I'm going to say, I'm going to call this OpenGL PAINT5D get. Right, so this section here is going to be specifically for this rewrite. And we are going to not be as commenty as we usually are, because we're going to try to get this so that we can kind of paste it in here. So in order to do that, we got to think, well, we need to indent it by one more so that we can kind of put, put comment characters around it after we're done with it and not have too much of any trouble. And so how are we gonna do this? So here's what we're gonna do. We're gonna do this, and then we're gonna do like something like 1, 2, 3, 4. So 1, 2, 3, 4, and we're actually gonna kind of make this section a little bit stranger than we usually make them. So it's intentionally like this so that we can cut this. So we cut this and paste it into over here on this side, and do you want to call it 8? Well, we can't call it this because that's what it's already called in let's just give the same exact name, right? So if we're gonna call it OpenGL, right, then why don't we just call it OpenGL PAINT5D get, right? So this is the version for over here, right? So actually, no, let's just do this. Return, and the tile value needs to be a U32. Like that. Let's not make it that ugly. Let's actually indent this one more time, right? Or does it need to be indented one more time? No, I don't think so. So define U32, and the problem with this is the defines are going to change depending on if it's where it is. So so I know we had some if-defs in here before. We did some fancy if-def stuff. So if if-def so I don't know how an if-def needs to work in shader code here, and we're gonna have to figure that out, because we want something that's going to be as easy as possible to kind of cut and paste here. So let's try to do something. Let's try to write something here. If we do like if-def pasted into OpenGL, you know, something, doesn't really matter what, and then blah 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 blah, something that doesn't matter, and then end if, right? So we're saying, you know, if this exists, then we'll do this code, end if, right? And also, we want an else as well. And else, we're just going to do nothing. Okay? That's not exactly how we're going to do it, but we just want to write some code and see if we can get that working, right? Can we? Is this proper? Can we do this kind of if-def in GLSL, or is it going to complain at us, right? We got to know if we can get away with that, because that's going to determine how we're going to write this C code. So let's give that a shot and see if we can get away with this. So we were in the middle of writing some code here. Let's just comment this out for a second and see if see what we got. Okay, syntax error. So what did I screw up? Unrecognized profiler specifier. So let's see how we do an if-def, and maybe if-def is not a thing in GLSL, I don't know. So let's give it a shot, and using ifdel in GLSL, whatever. So it looks to me that maybe the if-def is not going to allow... Okay, so I think the if-def just is not going to be something where we can put it in parentheses. The if-def has to be like this. That's what I'm guessing. So let's take that and see if we can get that working, right? So the idea is that this is not defined. This is complete gibberish, but it shouldn't be compiling because it's inside this if-def, right? That's what we're expecting. And then if we can get that running, okay, so that works, yeah, that works, cool. So what we can do is we can do, the if-def needs to be like if-def, macro, this is AAC 2020 open GL code. So something like this, you know, alright, so if def, like this, and then what we can do is else, and then end if. And then we're going to need the same thing over here, unfortunately. Or actually, no, we don't need the same thing over here, because we'll just undef everything. So undef U32, right? We'll undef U32, but when we define U32, if it is GLSL code, then it's uint, okay? But if it's not GLSL code, then our uint is like this, right? So our macros are dependent on so we're gonna have like a section for type macros. And then we can also, I guess technically there's another section for type macros, right? So this is the bottom section of the type macros section, right? So we could take this and paste it over here. And yeah, the formatting is just going to look a little bit different just because of the way we have to do this. So I don't know what things are defined. Yeah. Okay, yeah, sure. We'll just kind of have to wrap it like this. And then we just need to write the logic for this. So let's actually kind of like paste what we have over here. Like we already have some logic for the get here. And this function is mostly like input checks, declaring variables, so it looks like this uses another function that we're going to have to rewrite. And this could return a vec2, right? So we also need this function. If we're really going to do it like this, yeah. So let's take this function as well. And we're going to have to... let's just paste this here. And just say, you know, just do something like this, right? And let's consolidate all of the code that's going to be for our shader code. Let's just put it here, right? So we're going to rewrite all the code that's going to eventually be GLSL code, but we're going to write it in C code first and try to write it in such a way that it's generic enough that cutting and pasting it won't be too hard. And we're going to kind of keep this weird indentation style to try to make this as easy as possible. So over here, we're going to rename this as so we're going to name it OpenGL PAINT5D Pain Picks to Glock Picks, right? And instead of returning these, we're going to return them as a how are we gonna return these? We're gonna return it with a struct. We're gonna need a struct, I guess. We could just call it glow txy, or I don't know what we want to call it. Glow. Or we could just do this and glow tx and glow ty, right? We could just make it like that, and then we're gonna return. We will return. We'll return some variable. That's this thing here. Right, so so this is gonna be pretty obtuse here. Right? But we're gonna just make this struct and do some stuff with it and return it. The struct is up here. Declares an output parameter, and these outputs here, right? We can't do it as a output parameter like this. Like if we want to do pane pix to Glock pix, we got to do it this way. So, okay. And we're gonna have to write some tests for this as well. So this kind of sucks, but oh well. So we'll have to create the struct for it as well. Because we want to just cut and paste this, because we just want to cut and paste this into the GLSL code with, you know, it's going to be kind of hacky to kind of cut and paste this, but because we want to just cut and paste it, we're going to put the actual data, the struct, in this file as well. So we're going to say struct and do we just want to make this its own file? Because we're going to have to reference the other file as well anyways. That might be easier. It might be easier, honestly. And then we can have like a unit test function for it separately. Yeah, I think I might want to do it like that. So let's take this and say PAINT5D default shaders. Let's make a new folder called PAINT5D do we really want to call it that? Do we really want to make it call OpenGL PAINT5D? I mean, that's the namespace, so that's the namespace we're going for. Even though, don't you want all the PAINT5D stuff grouped together? I don't know, let's not be too picky. Does it even need its own folder, though? Yeah, let's just do it. Let's just call it, Or actually, how about reading it as, I don't know what makes the most sense here. It makes sense for me to have, like, all the stuff that's gonna be... Because eventually we're gonna have more than just PAINT5D. We're gonna have a lot of different stuff for, code that we're gonna write once in C, inject it into the C code, and then also make sure that it runs properly as C90 as GLSL code. I don't know what I want to do here. OpenGL C99. I don't want too many folders here. We already have this PAINT5D default shaders folder. I don't want another PAINT5D thing. OpenGL namespaced. Sure. And then we could call this, we could call it PAINT5D OpenGL, like that, maybe. And we could take all this code that we're working on here, copy it into here, paste it here. And then here we could just say, you know, include, and we're already in PAINT5 in lib, so / OpenGL namespace /P5D OGL. Alright, we could include it like that, and just say, we want this code to be written in a way that so that's what's going on here. So let's say at vid IID, it's 8:05, and the time is 1 hour, 4 minutes, and 20 seconds. So that's what's going on in this section, right? So it's going to get a little hairy trying to figure out how to kind of shim this code in there. So we'll use include, right, so that it's isolated into its own file. The reason we're going to isolate this into its own file is because, you know what, a lot of what we're going to write over here, a lot of this code that we're about to write is just a reference to the code we've already written, right? We just want to transcribe it into an OpenGL-friendly kind of way here. So this struct here, we're just going to open it up, and within the struct needs the semicolon at the end of it, I believe. But functions do not. Little things like this trip me up. And we'll just say glowtx and glowty, and they are both unsigned 32-bit integers, or are they not? So we may have used a whole bunch of different types for our math originally. However, well, let's try to stick to the types that we need. Let's try to stick to the same types that we use for everything else, but yeah, this is just gonna get ugly. So GLOTX right here, is it always a 16-bit integer? Like, do we need, so you know, we don't have the luxury of having all these different types in our GLSL code. It's just gonna make things harder. It's just gonna make things harder. So unfortunately, when it comes to the GLSL version of this code that we're going to construct, we need to just say that everything, you know what, you're all U32s here. You're all U32s. The reason you're U32s is because yeah, we don't have the option of working with all these different types. Yeah, so UNT32 is what we're going to go with. Now, do you want UNT32s or do we want integers? You know, because if we look at some of this code, like if we look at the texture sampling code here, the texel fetch or whatever, and we look at where we call the sampler, texel fetch, texture to sample, texel coordinates. So these texel coordinates, it's an int. It's an int. We need an int for those coordinates. And for this texture command here, a vec2 blah blah blah. Yeah, so we can do a texel fetch. We've already figured out that we can get a texel fetch working. Yeah, define texel fetch is a 1 right here, so we're using this texel fetch code already. But in order for us to do that, the texel coordinates here are an int vec, huh? So int vec would be the easiest thing to work with here. And if that's the easiest thing to work with, then do we want this or do we want just a just say int vec glotx gloty? The thing is that if we use an int vec right here, well, at some point we gotta use an int vec. So how are we gonna do that? How are we gonna get an yeah, we're just gonna have to be careful. You know what? Yeah, sure. So what we're gonna do here is so if we're in GLSL code, we have an int vec type. Yeah, ivec, or it's called ivec2. So we'll do iv2. And if we're not in GLSL code, we'll define iv2 as struct it's gonna be So we're gonna have to be kind of weird about this. So IV2 type is going to be struct OpenGL IV2 something like that. And then for the cast, actually no, I don't think we need to do cast. Yeah, maybe I'm wrong here. Hold on. So okay. I don't really think we need the U32. I think U32 is just going to complicate things. Let's get rid of U32 here. The signature is just going to be a little bit different than what it is in the C code we already wrote. Because we need to write it in a way that it's going to work both in the C code and in the OpenGL code. So macro, this is AAC 2020 OpenGL code, right? Or something like macro pasted from C into open something like that maybe makes more sense. Macro pasted from C into OpenGL shader. Something. It just needs to indicate that we cut and pasted it into the OpenGL shader code. So int32x, int32y, right? Because IVEC2 has, you know, the x and the y. And instead of this here, what we're going to do is we're just going to say, we could just call it glowtx and glowty, right? This is a little bit ugly of a name, but we could do that. So we could say, you know, IVEC2, and I don't know if we can zero initialize it, I don't know how that's going to work. And then this is going to be a IV2 over here, right? IntVec2, which is either this or this struct, right? Depending on how that works. Now, because we have this thing here, we can't have this struct here. This struct is only for the this is only for the C code, the struct. So we're gonna have to put it here, because once we're over here, once we're in the GLSL code, the IntVec2, it's just gonna be IVEC2, right? Okay. So now that we say IVEC2, what do we want to do here? We want to eventually do some work, but for now, we just want to get this compiling again. So instead of this being a U32, it's going to be int32. And, oh, actually, no. This still needs to be an unsigned value because it is it's a tile value. Tile quadrant, tile exponent, tile layer. Let me think about it. So where does the actual bit shifting happen? The bit shifting happens with this guy, but even bit shifting is going to take ints, right? And the value we're going to get out of here is going to be integer tile value, right? It's going to be some type of value. It's going to be integer. It's still going to be like for, yeah, so I think these need to be int32s. These need to be int32. So we have to kind of figure out what the best signature here is. And it's going to take a little bit of thought to figure out what that is. But yeah, I think this makes more sense. So int32s for everything. Keep it as simple as possible. And then eventually in this function here, this getter function, we're going to have some bit shifting craziness. But let's keep it as simple as possible for now. This tile value, though, we need to declare that somewhere, right? So int32 tile value equals, we'll set it to 0 for now. And for this, we could do, we don't really need anything, do we? So type macros, we're going to have to undef some things. So we're going to undef int32 as well, and then we're going to undef the ivec2. And in fact, what is the actual order we do this? int32 ivec2 u32. So we're going to need a uint32 eventually, because the uint32 is kind of what is stored in the texture. And when it's GLSL code, that's what it is. If it is in the C code, then it's one of these guys. So yeah, this is kind of, this is going to take some time to get right, unfortunately. Okay, so now that we have these, let's copy all these, paste them down here, just to have them in the same order. What else? I mean, that looks like a good start. And the nice thing now is, as we're fleshing this out, we can at least have some syntax validation as we go here, right? So let me delete this. Oh. Right, we'll have some validation of the syntax we've been writing, rather than it just not working. No such file or directory. /OpenGL namespace and libchan top. What do we call it? Let's see what we called that. We called it, so in our library, OpenGL namespace. Oh, okay, namespaced. So how do we want to change that? Obviously, namespace versus namespace is kind of like, We could just call it OpenGL, right? And then have C code in it, right? We call it OpenGL. People are going to know that that's where to find OpenGL code, but it's not all the OpenGL code. We could call it C99 GLSL. I don't know. We got hack code. Like that. And therefore each thing is 7 letters, right? 3, 4, 5, 6, 7. Whatever. Sure, why not? We'll call it hack code. That changes whether or not these files exist or not, right? Keep in the editor, no. Hopefully, don't make too many changes. Okay, yeah, so we'll call it hack code, sure, whatever. And then, over here, where we have those includes, right? We have one include, right? That's the only include here. We'll just call it OpenGL hack code. Sure. Right, because it's kind of hackish what we're doing, so we'll call it hack code. Why not? Unused parameter, yeah, unused parameter. I know, because we're kind of trying to write this. So we're gonna have to use these before we can get it running. So let's just try to write all of it right now. Let's find the functions that we need to write and just kind of start transcribing them now. And see, we'll probably have to go backwards direction here to find where this is being used. Yeah. Okay, so for this function, right, we have a lot of different types here. And we're going to change that around. The asserts, we're not going to be able to assert anything. We're going to have to be pretty just careful here. No asserts anymore. No trap values, right? We're going to write everything kind of very carefully. So all the core stuff here can be taken. So this int 16 cast. Oh, so we're also going to need this function, huh? So it's just this code we need. So let's take this. We can paste it into this PAINPix to GlockPix. Yeah, so let's paste this into here. And this GTX, GTY. Just call it glow tile like that. And you can get rid of this. Just call it glow. So we don't wanna make this harder than it is to reformat. So just call it glow, right? That already exists. So these different quads here, so all these things can be IVEC2s. So we could do... Alright, so where we see Tempe, we could replace that with... where we see Tempe.x, we can go tem.x. Then wherever we see temp y, we can do tem.y like that. Assert air checking? No asserts, no air checking. Just being careful. The tile quadrant is already included. This OX, OY, we could just call that qua. Just keep a note of what these different things are. Yeah, so anywhere we see qua, right, we'll replace them with the qua.x or qua.y. Now, remember, this is, in GLSL, you can do operations all together, right? Like, you can, like, add vectors, and that works. However, we're going to write this code in a way where it also compiles as normal C99 code. Because we want it to work on both systems, right? So... So diagpix, we're just going to call it diagonal. And diagpix can be at int32. Okay, and wherever we see diagpix, we're just going to do, we're just going to say, you know, dia, right? Dia and dia. There is a function here. We're going to have to say AAC, instead of AAC 2020 PAINT5D, we're going to call this one OpenGL, right? So this is the OpenGL version of the function. And the OpenGL version of the function is not going to have any cast on it. It's going to be written explicitly so that it can be used with this. And let's line it up with the actual parameter, sure, like that. Actually, we might have just enough room. Now, how do we do this? Yeah, and where we're saying width here, we can just get rid of width here. You can reference the function that this was based on to know if that's width, but in the source code, you're just not going to know. You're just going to have to... And that just gives us... That just makes things more convenient for me. I can just make this kind of very clean. So lay can also be IVEC2, right? So we can do Actually, let's group these based on type, I think. So this is OX lay and OY lay. Okay. And so, since this is going to be a very painful transcription of the logic, we're gonna really hope that, you know, our tests were good enough, right? Because, however, we're going to also test this code. We're going to, like, compare it. We're going to test this code just by comparing it against the AAC 2020 versions of the same functions, right? That's the way we're going to test it, I believe. That's how we'll do it. Yeah, so layer here. We have so this lay is an offset. Hold on. So this lay here is an offset, and it's lay.x or lay.y. Okay, lock tx, lock ty, those are inputs. Now the thing is do we want this as do we want it as lock tx, lock ty, or do we want it as a IVEC2 called lock? IVEC2 kind of would make sense, but however, we want the function to kind of resemble what it's based on as much as possible. And for that to happen, we're going to have to if that's what we want, we can do that, but we're going to have to make sure that as we write it, we keep in mind that it needs to somehow resemble the function it's based on, right? And we can remove a lot of commentary, though, you know, because we don't really need the commentary anymore. So this diagonal is only needed right here. So we could put this over here, like that, because it's only used down here. And then we can kind of see how we're using temp and then whatever, how we're whittling down like that. I kind of like that. That kind of seems to, that appeals to me. Also, let's not use up too much room here. Okay, so once again, we want to make sure that everything, all these borders are going to be subtracted by 4. So 1, 2, 3, 4. And 1, 2, 3, 4, right? So these borders have to be subtracted like this, so when I paste it into the GLSL, it just, I can put comment characters on both sides of it. So this max core, where are you coming from? Max coordinate looks like it's just not accounted for here. Now, I was under the assumption that max coordinate was PAINT5D to GLOCKPIX, PAINT5D to GLOCKPIX. Let's look for max coordinate here. So this is what we cut and pasted, and max core is right here. Okay, so we're actually getting it from a function here, right? So max core equals, you know, this to max coordinate. Okay, fine, we'll take it. We'll take that, and let's paste this down here. So we'll have to make OpenGL versions of these to get the max core, and then this is diagpics. Do we want to keep it as diagpics? Just because that, right? Or max core. Why don't we just call it max, right? We're keeping everything as... Ooh, no, max is probably a keyword in GLSL, right? Max. So let's not do that. Let's call it MC. Right. So int32 MC is max core like that. Right. So keep a note of what they originally referred to, right? So we have something kind of nice here where the functions that we need to call, the helper functions we need to call, we're calling them right ahead of time, and then we can kind of group all this logic nicely. That's pretty good. And then returning here, we're not returning this, we're returning glow, right? And that's right. So we're returning glow, and glow is the glow tx, glow ty. That's what's getting returned. So declare variables. To make this section, right, we'll make kind of these nice little sections for everything. And then we'll subtract 4 characters, 1, 2, 3, 4. 1, 2, 3, 4, so that we can paste it into the code we need a little bit easier. Okay, so now we have these 2 new functions that we also need to make, so we'll have to make those as well. This is going to get just hairy, isn't it? Type macros. Yeah, let's just keep on rolling here, because I think we got something going here. So int32. Okay, that'll take a tile exponent value. And then some logic goes in here. And for the diagpics, same deal. An int32. And it will take a tile exponent value as well. And we might as well kind of like, you know, we might as well kind of put it right there, like that, so we can see it. I don't know if we want to do like int32 like that. That's kind of weird, but sure, why not? Okay, tile exponent. We're gonna need some dashed lines. Usually this would be dashed by 2, but it's gonna be dash line I3 x64. Because we want it in set 1, so it's lined up here. And these dashes are going to separate the functions. It's also going to make it easier to see this column limit that we're creating, right? Because we have this kind of stricter column limit that we need to enforce as we write all this stuff out. Okay, so I got these OpenGL versions of the PAINT5D conversion functions that we need to write. And yeah, this is a lot of work to just manually refactor, but I think it'll pay off. So let's keep on going here. And, you know, after we get to 2 hours, we're going to try to do maybe like, I don't know, we'll try to do more push-ups. Okay. So let's go find this function here. So we should be able to look upward to find it. Okay. So it's just really a lookup table, right? you know, if it equals this, max chord equals this. And we're not going to use this, right? We're saying that using a tile exponent of 8 was a bad idea. So let's just take this here, just paste it over here, and also let's just make an array here. Also, no, we're not going to make an array, because an array, even though an array might be the more efficient way to do it, an array in GLSL is not quite declared as it would be in C code. Like, if we look up here, we actually have an array, right? This array here. We can see that it's the type, and then this, right? This is not the exact same syntax, right? Or maybe it is, but it's just the constructor. The constructor uses different brackets, right? Unless we can use a define to create those brackets that we need, and I don't think we can. I don't think a define allows us to do that. Or maybe, actually it might. I don't know. It might, but it's kind of risky. Like, maybe we could make a define to change how that's constructed. But right now, we just want something dead simple. So, max core, so it's going to be an int32. And but I don't really like how that's like that, though. Here's what we'll do. In here, we're going to say define right, we'll use these defines to kind of shorten up this code a bit. And then we can keep these little checksums here, and the checksums are already nicely lined up to where they need to be already, so that's cool. Now, we might want to... I usually like to anchor my defines, kind of like, if they're for a specific function, usually I would put them in the outside, but in this case, because of the difference with how we're writing this code and how these sections need to be, I think this is the cleanest way to do it. So, undef. Okay. Tile exponent, max chord. What else do we want to do here to get this working? I think that's all we need to get that working here, right? So if we're kind of sure of ourselves, as we get more sure of ourselves with the code, we're just gonna have to, start just blocking stuff off here, like this, right? And being like, we're absolutely sure this code is done. And because we're going to have to cut and paste it eventually into the shader code, and we just want to have some confidence that it's, like, done, right? So, and also, we're not confident this is done because we have a return statement we didn't use. So, let's take that return statement and put it over here, like that. I think that works. Yeah, so this is going to be painful. This is painstaking. But we got to do it. So let's find this function now. Let's find where you are and kind of transcribe you. So if we go backwards, so it's being called here, so that means that it has to be declared somewhere up above. So here we go. So we have a lookup table. However, with the lookup table, the problem with that lookup table is cutting and pasting it into the GLSL code isn't going to be very good. So let's look at what we got here for our table. And instead of using a table, we're going to take all these values. So this is a checksum. We're going to take these values and we're going to paste them into here for a second. This is the correct table we want. This last value we don't want, right? Because we're not going to support the last value, right? We're not going to support that. So, so these are the values we're returning, correct? Yeah, these are the values we're returning. 255 would never get returned. So if we want to continue with that pattern, which I guess we want to, so let's do that then, if that's the pattern we want. Put the 0 in front. And so this is big. If big branching statements like this are not a good idea. Big branching statements like what I'm about to do, bad idea for shader code. However, we just need to get it working first, right? We need to get it working first. We can worry about optimizing this later. So I don't know, like that. Almost feels like a switch would be better, right? Or we could just, add these together, figure out what they actually are, right? So, so 128 plus 60, yeah, let's just do that. Let's just add these together and kind of see what they all are. Okay, 192, not surprising. $224. $240. This will be 248 then. $252. And what would this number be? So eventually we're going to want to put this kind of stuff in an array. However, at this point in time, we do not want to. So this else, and So if it's out of range, we'll set it to invalid configuration pixel. That's what we'll do. To-do. So eventually we want to make it into a lookup table. Alright, so we want to make this into a lookup table, but right now, we just got to get it working, right? So, we're just going to say at vid IID, time is, and by the time we write that, right? So yeah, we want to get this working, but for now, it's just going to be like this big if-else. Define e as till exponent. Or no, t is till x. And I don't know, I have... Shouldn't that just be a D? Yeah. So the maximum tile exponent is 7 for this system. This is not D. This is D for diagpix. And... Alright, so in 32 diagpix, tile exponent is already in there. And then over here we'll do return diagpix. Alright. And then over here we'll do the undefs for this. Okay, cool. So now we have most of these functions kind of stubbed in, and not sure why we decided on the number of things that we decided on for here, but let's just keep on doing that. So, like, that is kind of nice though, like that. Being able to do that. So yeah, let's take what we have and make sure it still runs. Like, I'm sure we made some type of syntax mistake. Fix our syntax mistakes, and then just keep on plugging away here. E undeclared, first using this function. Okay, so let's go over here and say, well, what's up with that? Because I thought we used a define for that. And... oh, we did something stupid, didn't we? We did, T and D. Oh, we forgot this one. Okay. Let's give that another run. Unused parameter. So let's go see where that's in the code. And it is in 133. And the reason it's not used is because, well, we haven't written any of this code yet, right? So let's get to writing this code now. So like I said, it's just going to be a transcription of what we've already done. So let's go look for it and find it and write it, right? So let's go and figure out where you are. Let's go back to the top of the file and then search downward. Okay, so here you are. Tile value is not an output parameter anymore. It's outputted as the return of the function, and that's fine. So the bounds checks, we can skip this entire section. It's all bounds check. Declare variables is kind of like, do we want to... I don't know. So a lot of these things... So we use glow here, right? And... glow is returned from here as a IVEC, so it would make sense in this function that's going to make use of it that that glow would just be IVEC 2, and it's just called glow. And why do we have tile value like this? Because it's return, right? So that's the return value. So this is glow TX and glow TY. That's what it originally was. Glow dex, glow com, glow array, like all these things. We'll probably need them all, except for if they're commented out. We don't, obviously. So let's take these guys. So they're already int32, so that's nice. Do we need anything else? Doesn't look like it. But then we have this function call here, which has quite a lot of stuff in it. Let's take this. Excuse me. And, it looks to me that it's just kind of taking a lot of these same things. However, this last parameter is just going to be either glow or what does this take? So let's go look up at it and see. Oh wait, you're nowhere, huh? Paint pix to Glock pix. Do we not do that? Oh, whoa, hold on. Okay, there we go. And how does that look? So local TX and local TY. So it's going to take these two, local TX and local TY. So we'll keep local TX, local TY like that for now, because I think no need to change that anymore than it already is. So glow TX, glow TY, right? So that means that this glow equals this function call here, and we can remove these parameters here, right? And we can do this kind of style. Lately, I've kind of liked this kind of style as opposed to this kind of style. I guess it's more Pythonic of a style to write the code in, but yeah, I kind of like it. So I'm going to keep up with it, even though the first time I saw this kind of style, I thought it was ugly as hell, but now it's like, I kind of like it now. Let's stick with it. Okay, so once we have this global coordinate here, this Glock pix, right? So this is glow TX, glow TY. We could also name these sections the same, but we really don't have room for that. Let's not do that. And also, those comments are going to end up in our shader code, so our shader code is kind of open to everyone, so do we really want to expose all the secrets of what we're doing directly in the shader code by having all those nice little comments for everyone? I don't know if we do. So map span is only this double check component index. Okay, this is just checking it. This is a function to check it, but we just inline the code here. So we'll take this inline code and just roll with that. So glow dex something or whatever. Glow dex and glow com are already here. And then glow tx and glow ty. So this is now glow.x, and this one is glow.y. And the map span is just 512. This is RGBA. We're not going to let anyone know that, though. We're just going to keep it like that. But now we are. So, if you know what that abbreviation stands for, component, then that'll cue you in. But yeah, let's just remove some of the defines and just kind of simplify this code as much as possible, right? So we're going to write it in a much neater way that's not as cluttery, just because we're going to have to get this into the GLSL shader. So define bin whatever the heck. We don't use that anymore because we use this bitpack get function. However, this bitpack get that we're doing here, we cannot really, we can't really do it like that. The thing is that this, right, this is a pointer. We can't be using pointers. However, maybe we are sampling from a different texture, right? But it's going to be hard-coded for that texture. I guess we could keep it like that, just because it's going to be... no, because it's just going to make it harder to do. It's just going to make it harder for this to work if we try to make it work with another texture or whatever. It's just going to make this a lot harder. So let's try to keep this as simple as possible. So this bitpack get function, do we really want to... How are we going to rewrite it, or are we going to inline it? For manageability of the code, I think it's better if we just kind of inline everything that we need, even though it makes more functions. So we are saying here that we're going to have a function like this. But its signature is going to have to change, though. So first of all, let's just get rid of this stuff. And the CPU picks, it's going to be hard-coded for a certain one of them. And the tile value is just what it's going to bring back. So tile value equals a function call to this, right? And then we can remove this, indent this, remove this extra parenthesis here, and this is going to be OpenGL, right? OpenGL bitpack get, right? Because we're going to write the OpenGL version of this function, and return via output parameter that we're no longer doing that. So tile val equals old val. Okay, returning via an output parameter. Where do we do that? Now set using... Oh, got it. It's set using this. Okay, cool. Even have a little commentary telling us why we're not doing this. So it's set using this function. That's fine. So the tile value is going to equal this. And then we're good. We return it. Okay, yeah. So that looks good to me. So let's keep with our section names here. So we have like a declare variables kind of thing here. Let's do that over here as well. So let's kind of steal that. Because it has the right indentation level here. And do we just want to keep another section that also says calculate? I don't know. I don't know how I feel about that. What are we calculating, though, now? We are calculate, I almost feel like just calling it calculate output. Is it really calculate, though? It's more of like a get, right? We're going to take this to get the global location, and then we're going to do our bit shifting craziness. Get pixel and extract tile value. Well, that's really what we're doing. So why don't we just name it that and call it good, right? So now let's paste this over here. I don't know where we want to put the return. Like, do we want the return outside of this section that we're labeling, or do we want it inside? Well, what do you do with the other thing? We just return it on the other side. Sure, why not? So if we take this, we'll cut this out. Actually, no, we'll not cut it out like that. We've got to be very, very precise about this. This is kind of, like, obvious, but I want to kind of maintain some symmetry in my code where, you know, if I have these labels on everything, you know, give everything a label, you know? So let's give over here a return from function kind of thing as well, just so that everything is a little bit more uniform in the way we are writing it. And then, over here, up here, we would need, we're not gonna, no, we're just gonna keep it like that for now. So another thing is, these section dividers, they are inside of functions. Does it really make sense to keep it these strong lines, right? This kind of violates our line hierarchy, because we got dashed lines here, and then all of a sudden we're not dashed lines anymore, right? So, I'm thinking... also, we got like 40 push-ups to do at least right now. So I'm thinking lowercase these a bit, right? Lowercase these headers, and also I don't know about dots, though. I don't know if dots is the way to go here. I mean, it would definitely helps to make everything kind of less intense. However, it's not quite symmetrical anymore. You know what? I don't know. Maybe that... Is that horrible, or is that okay? I don't think that's too bad. I think that's kind of good. I think that works. It's just a little... So for this, we're going to add one more underscore, so that way we can keep the kind of spacing that we want. And also have some spaces between these sections. Okay, that looks pretty good. Yeah, we just don't want to... We're getting kind of designy, but it is kind of important that the code just... It looks good. I don't know what to say. It just needs to... our eye needs to be able to go over it in a way where we can just spot out any irregularities by just looking at the code. So this... we'll just make this lowercase... Or actually, no. We can keep that capitalized, because it's calculate, and then this is the thing we're calculating. And then for this, we will... I don't know, just put two things there, like that, I guess. And then up here... This will be lowercase. And declare variables. I think we already did this, but whatever. Oh yeah, we did, because we had the double underscore. Alright, cool. So what else do we have to do here? Well, I guess we had one more function that we didn't write yet, right? This bitpack get needs to be written. So bitpack get, let's go look for it and write a version of it for... Let's write a version of it for bitpack get. Okay, so we gotta go in a backwards direction here. And we're gonna have to change around how it's called. So this needs to return a U32. Now this tile value is int32. Does that make sense for the tile value to ever be an int32 value, right? Because we gotta, like... We're going to have to do, like, fancy bit shifting stuff with tile values eventually, so I think that tile values should probably always be U32s. So anywhere we're using tile value, I think that should actually be a U32. And if that's the case, though, and we have to return tile value here, that also means that this is going to be a U32 here, right? Everything's going to be int32 except for the actual value, right? I don't know. I don't know if that's how we want to roll with this. Yeah, let's do it like that, because it's eventually packed into pixel data. We're never going to want to use it as a signed integer value, right? We're always going to want it for its bit pattern. So, okay, sure. So... bitpack get, so this global component and this offset dex oh, hold on. So a texel fetch is never, wow, I'm just being spammed right now. A texel fetch is not going to ever use the once we have the global XY location, we're good. We don't need to... Once we have the global XY location, we do not need to... We're going to have to write, like, a fake texel fetch command, aren't we? Yeah, we are. Yeah, this command here doesn't need to know about this stuff here, because it's just going to use glow. Yeah, it's just going to use glow. So, yeah, so this stuff doesn't matter. So I'm going to take this and over here we're going to say U32, it's called texel fetch, right? It's a texel fetch. So we look over here, we see, oh, it's texel fetch like this. So we're going to take that, and we're going to say, you know, AAC, AAC 2020 PAINT5D. Right, so it's going to take to do yeah, so we need a fake texel fetch command, and then in the in our pixname object in the data, we have an array for PAINT5D right here, right? So we're going to take that and we're going to paste it right here, and this global component right here, right? Right. So this is our fake texel fetch, right? So that logic needs to be somewhere, but it's going to be handled by the texel fetch. So on the GPU side, we can have this just XY value, and we don't actually need any of this. But it actually is needed somewhere, because we gotta get this to where we can kind of paste this, and because this is only going to exist in the, this needs to actually be outside of here. So this here needs to do not paste into GLSL code. So this should not be pasted into the GLSL code, right? This is like a little polyfill. So these are going to be polyfills here. This is going to be like a polyfill section, you could say. And I mean polyfill in the JavaScript kind of way, right? So GLSL polyfills, right? So this is GLSL polyfills, and we do not want to paste this into the GLSL code. It's just to get the code working on the C side before we paste it into the shader code. So GlodeX, GloCom, IVEC2, and U32. So we have to define those. And because we are so this struct that we put here, technically it's a polyfill. So let's take that struct and move it into here, right? Okay, so this struct, okay. So this is our int-vec thing, OpenGL IV2. We have enough room. We're only using it in this one place. We have enough room to actually namespace this in a way where we can find it a little bit better. That's a really long-handed name, but... something like that. Not too long. Want it to be... give us some more information. But then, make sure that we can... yeah. That way we know this type belongs to the library we're working on, right? We have enough room where we can be a little bit more verbose about it. Sure. So here's our Texel Fetch polyfill. And what we're gonna do is down in bitpack get is going to use this stuff here. So let's take this for a second. So there's all these kind of helper functions. Let's put this over here. And this is IVEC2. This is int32, right? Everything is going to be usually, if it's a single value, it's going to be int32, except for the bitpacked pixel value, which is a u32. Right, so we have something like this. And we want a define for this. So if this is OpenGL shader code, then Texel Fetch will be not this. It'll actually be Texel Fetch. Right, it'll actually be Texel Fetch. And otherwise, we're gonna define Texel Fetch as this like helper function, right, that exists up here. This little polyfill deal. So TF for Texel Fetch. And then in here, what we're going to do is we're going to use our fake Texel Fetch. So Texel Fetch, right? Texel Fetch takes this one coordinate, right? And then it returns it, right, as a U32. So now let's look for a bitpack get and see where that's coming from. And then we're going to do, I guess, 60 push-ups and everything. So bitpack get, okay, we're already here. Let's just kind of highlight some of the things that matter to us, right? The parameters. Input checks. We can skip all the input checks. Okay, variable declarations here. Old val, array dex, blah, blah, blah. So this math is not going to quite work for us, is it? Because we're actually going to be looking at an entire pixel this time, right? We're actually going to Texel fetch the entire 32 bits, and this math is actually working on the byte array. So we're going to have to be a little bit more careful about this. So a lot of this logic is going to change a lot. So instead of a var U08 like this, So U32 var U32 equals the texel fetch, and then the tile value equals this U32 variable shifted over by the offset dex times 2, because there's 2 bits per offset dex. And once we've shifted it over, we have to mask it off. So if we see this, we see we're having this shift over, and then we do and bin 001. So let's do and let's save some space here. Let's copy and paste this for a second. And keep it in terms of variables and then their values. Just because we don't have much room. So alright, we're going to shift it over, and then we're going to bitwise and it with this. Right? And then we'll return. And then we'll return it, right? And we'll define what that is. Define bin 011 as 3. And then we'll undef it over here. Alright, so now we have this getter function. Right, it just unpacks it. We don't got to worry about the packing logic. We only have to worry about getting stuff. We don't have to worry about getting and putting, because that is only on the CPU side. On this side, we just want to be able to get the value, right? Okay, so that looks pretty good there. Okay, so now the next thing is just to get this compiling. And then once it's compiling, we're going to have to write some tests for it to make sure that it works properly, right? And, IV2, unknown type name, IV2. So let's go look at that. I know we have some stuff outside of here, don't we? Yeah, IV2. So IV2 it's not going to be our C code. So IV2 is going to be... Where's IV2? IV2 is used in here somewhere? Oh yeah, it's returned right here, okay. So then also we forgot to undef and undef. And if we forget to undef what we define, it'll give us a big headache, so we don't want to do that. So that looks good. We don't have any defines for here, but we have these 4 defines here, which we undefine later. All these sections don't have defines for those types. We have some defines to make some things shorter. Okay, and then we undefine our type macros here. So that indentation should be the same up here. Yeah, that indentation. TF for texel fetch, we forgot that one. So U32, I32, IV2, and then TF for texel fetch. Okay, so let's give that a run. Unknown type name I32. What did I screw up now? So int32 must be referenced somewhere up here. Int32. So is there a U32? Oh, U32 is return because it's that, but we also need the int32. Fair enough. Okay. So it looks like we're almost there. And the reason why we're going to write it once in C code and then cut and paste it into the GLSL code is just because all these little mistakes that we're making, it's going to be much quicker to do it, figure it out in the C code than it is if we keep on screwing it up in the GLSL code. So OpenGL PAINT5D. Really? Is it declared in the wrong... Is this called... So it looks to me that, you know, here it is being called. And here it is being declared. So what's the problem? Is the case correct? Yeah, so where we're calling it from, the case is somehow wrong. And I honestly don't know what the difference is. OpenGL, PAINT5D. Oh, do we do the D capital? So what's the difference between this and this? Because it looks the same to me. Okay, hold on. I'm going to have to paste this to another monitor because I have no clue. So this thing right here. So here's the call. Here's my call. And then here's where I'm actually declare. Oh, it's the namespace. I guess it should be a lowercase. It doesn't really matter to me, though. You know what? I'm gonna keep it uppercase. You know why? Because it's just easier to read that way, right? Because this is all uppercase and this is all lowercase. That makes it a lot easier to read. It's OpenGL, whatever. I'm just gonna say screw the public-private thing here. It's the OpenGL something namespace, right? So we're gonna forgo. Yeah, and also this PAINT5D. PAINT5D. We'll make them capital. And you know what? Anywhere else we're gonna do that. We're gonna we're gonna take this. Yeah, anywhere we see that's not right. TUCMD, right? PAINT5D. Yeah, anywhere we see PAINT5D in here, we're just gonna say that should be capitalized. And that just makes it easier to... That's going to make it easier for me to read. It's already a special namespace as it is. Let's not worry about if it's public or private. It's just the OpenGL namespace. You want to stick with that everywhere? Well, this has to be that way, because that's just the way it is in the code. Let's actually keep this one lowercase. So let's go back here. Okay, so we think we changed the case to everything to be consistent. Implicit function declaration. AAC 2020 PAINT5D polyfill texel fetch. Okay, so what do we do wrong there? Let's go look at that. AAC 2020 PAINT5D texel fetch. It seems to me to be... This is just going to give us... Oh, texel fetch has this capital F. I'm going to do texel fetch like that, because I don't want to have to deal with things not matching, because I don't know... Yeah. Now, where we're using this, TF is for texel fetch. Texel fetch, that's how we spell texel fetch in OpenGL code, I'm pretty sure. Texel fetch, camel case. Or is it? Hold on, let's make absolutely sure. We have some... Yeah, texel fetch is camel case. Okay, cool. And the other thing here, though, is... Hold up. If we want to use a texel fetch, it needs the texture to sample, the texel coordinates, and the level of detail. So if we look at our texel fetch polyfill, right now it just has this, but if we really want this to work properly, we're going to have to do some weirdness here. We're going to have to say, like, so this is the polyfill, right? So the level of detail is the last thing. Okay, so these we're going to have to do like a little no-op here. And we need the signature for the texel fetch to match what it is in the GLSL code. So that is why we're writing this here. So at vid IID. Okay. So, the reason why we're writing this here, these no-ops here, and making these parameters that we're not doing anything with, is because this signature here for this polyfill of texel fetch, it needs to match the same signature that's actually going to be used in GLSL code. So you see texel fetch here has the texture to sample, the texel coordinates, and the level of detail. So we have to keep it like that. Now, the next thing we want to do as well, let's see where that's being used. So TF for texel fetch. So for some of these parameters, we're going to have to do some weirdness again. So PAINT5D is the texture to sample from. Call it P5D. The level of detail is always going to be 0, right? So, sample. Okay, so here's some commentary. So this P5D thing, right, we're going to use a macro. All right, we got all this macro craziness here. Define P5D if we are in our shader code. It's going to be PAINT5D. And that's because if we go into our code here, for our shader code, you'll see that for the sampler 2D, PAINT5D, right? So that is, when we're doing our texel fetches, right, we can see this arg001 is used in texel fetch here. So PAINT5D is the texture, right? The texture sampler, this U sampler here, is the texture, if that makes sense. Or you think of it as the texture. So it's going to be PAINT5D within when it's injected into our shader code, okay? Otherwise, if we're not going to use it, right, we can't really use this token, right, because that's a specific type. If we're here, we're just going to say that it's, you know, 0, right? So, otherwise, we just throw a 0 at it, right? So now let's look at this. So P5D, so there. Now we have the texel fetch kind of polyfill here. So we have code written in this kind of awkward way where it's going to be easy to kind of cut and paste into our shader code. So let's let's try to get this running, and once we get it running, we're going to say that we're at a good stopping point, because we're almost at 3 hours. That means 60 push-ups if we're doing 20 per hour. So we screwed up the signature when we rewrote it, so let's go over here and look at our polyfill here. And the first comma here, we can't have a comma on the first one like that. Okay, cool. P5D redefined. So somewhere I think we forgot to undefine something. So lib paint5d.f define paint5d. Let's go find this, because we should have gotten rid of this. So here's a define paint5d tau and whatever here. Do we have the same undefines at the end of this section? Well, it says undef right here, undef p5d. However, maybe that's not the... I'm not looking at the right code here. 3371. So if we look at 3371... it's happening somewhere earlier. Wait, hold on. Am I not looking at the same code again? So hold on. Oh, I forgot to undef it, right? I forgot to undef it, but where I forgot to undef it was over here. So we gotta undef it here. My bad. I thought I made the mistake in a different piece of code. Okay, so now that we're running... Alright, now that we're running and the code still compiles correctly, I think we're at a good stopping point. So what we've done now is we got, like, this rewrite of some of the functions we wrote on the GPU side, and we've rewritten them, taking out all of the certs and all of that safety stuff, right? And we transcribed it from the code that we already know that works, because we did the tests on it. So the next thing we want to do is we want to test these individual functions in our unit test code and make sure that whatever goes into I think the easiest way to test this would be to put we could iterate through. This could be a last test to see if the GLSL code works. We just want to run the... Assuming that we kind of did all of this correctly, the only function we want to test for proper functioning is just this function. We want to test this function, make sure that it is able to get the exact same values that the CPU side version of the function gets. And if we can make sure that this function works, then we don't have to test all these individual pieces, right? These individual pieces were transcribed from the GLSL code, right? So, yeah. So the other thing I'm wondering about is I have not seen my test run in a while, and I thought that we had like this divide by 20. Oh god, 20 was a bad number to do. We had this thing for the unit tests where we would only run them very infrequently to make sure that we didn't lose time by like running the tests all the time, but I haven't really found them ever to randomly run. So I know if we do like a 0x777f, we should be able to find... No? Or was it 7? No, it's 7FFF. My bad. So this is 1 and 20, and whatever is happening here isn't quite working. So what if we do like a 1 and 2 and try to run this? Because I was expecting to get those unit tests to run more often, but that's not what I was finding. 1 and 20 just doesn't seem to be frequently enough, or... So, okay, there we go. So the code does kind of run sometimes. So let's give this a run. This is going to take like a minute. And let's just say 1 and 20 is not frequent enough. Let's say, right, when it gets stuck here, we know that our tests are running, and that's fine. I just want it to happen more often than what 1 and 20 was giving me. So that's fine. Let's change that 1 and 20 to like a 1 and 10 then. Right. Or, yeah, let's just change it to a 1 in 10. And we're going to expect that randomly it's not going to run, but that every once in a while it will. Yeah. So, yeah, so the next thing you want to do is write some tests for the OpenGL polyfills, or the C versions of this, right? We want to write some tests for it. We are going to try to be confident here and say that we know what we're doing, and that that we're going to be able to just throw this in here. These macros, we want these macros in the code, right? Yeah. So how about we kind of... Let's do macro, this is GLSL. How about that? And let's think about some of these names here, right? Like, if we want to block this off like this, we're going to have to make these defines a little bit shorter. PAINT5D, OpenGL, whatever the heck. Let's just call it... Let's rename it and call it something else. Let's call it, keep the namespace to tell us to know where it's coming from, and call it that. How about that? It's OpenGL IVEC2, right? Within the AAC namespace, right? And we might want to put it in a different file eventually, but let's keep it like that. Replace, replace, and replace. There. But now we have enough room. And for this thing, instead of PAINT5D, we're gonna call it same deal here. So if you see this, we're gonna call it AAC 2020 polyfill texel fetch. Replace, replace. Okay, and now we have just enough room where we can kind of section this off, right? The idea is to kind of make this nice solid block of code that we can just kind of cut paste to where it needs to be, right? And so now this is not quite terse enough, or we need to move it over a bit. Like if we want to get this indentation how we want it, well, first of all, we move that over here like that. Put this over here like that. Remove one of these extra parentheses. And then let's do the same kind of formatting thing here. So okay, so same formatting there. And let's keep on rolling till we get to the next obstacle here. Right, I mean, we could easily kind of condense this a bit. Where to condense it is what I care about. Let's do it like that. Sure, why not? Okay. Okay. And let's put the commentary somewhere else. You know, right, just put the commentary there, and then we have more room to keep on going here. So glow is, so again, we'll say, you know, that's what glow is all about. And, you know, we're making a big commitment here. We're kind of saying, we're kind of being confident here and saying, you know what, I'm pretty sure this code is going to work. That may come to bite us later. Right, because we're taking all this time to section off all these different pieces of code, and then eventually we might find out, oh, you are wrong, you didn't transcribe it correctly, and there's something horribly wrong with it. But we're gonna make a bet here that we have done this correctly, and we're gonna kind of close it all off as this like little package of code that we're never ever gonna change. Right? We have remember, different data, different problem. Right? So this code is just formulas that work with a very specific data layout. It's never going to change, right? If we have a different data layout, we'll have to write different code. So now we have this PAINT5D get function, right? So all of this is for PAINT5D get, right? All this code is just for PAINT5D get. So we have this big payload that we want to shove into our GLSL code. I'm happy with that. I'm happy with how we've kind of created this code. Let's make sure that we didn't do anything stupid while we were transcribing it and moving things around. Let's make sure that it still runs. So it still compiles, so that's good enough for me. Okay. So let's do a git bash here and state kind of what we did here. So git status, git add dot, git commit dash am, GLSL versions of PAINT5D. Alright, that's what we did, right? We have all those helper functions to do it, but essentially what it is a GLSL version of PAINT5D git, right? Okay, so now that we have that, let's look at our push-ups. So this was from yesterday, or not yesterday, but it was from a different day. So what I'm gonna do is, this was for Monday. I'm gonna make another thing for the total for the. So usually we do no more than 3 streams in any day. So this number is, so this is fine. However, let's make another thing for total this week. And we're just going to put 60 here, because we're about to do our 60. And so we're just going to trust ourselves to get those 60 done, because we've already put the numbers down. We can't change it now, right? We've already put the numbers down. It's as good as done. We're going to stick to our word, say it's good as done, because we've put the numbers here, right? And we're going to rename some of these things. So we have a stream total of 3 hours here. And this one's 3 hours, so. Okay, yeah. So that's what we're going to do. We're going to do our push-ups. But we're going to stop the stream, we're going to do our push-ups, and then we're going to make our food, because it's 9, so we have to make food and do our exercise and stuff. So, did I say 30? No, we got to do 60, because 3 hours, 20 per hour, 60. Okay, anyways, I'm out of here. Later.